Welcome back to the deep dive. We're always looking for ways to be more efficient, to save a few seconds here and there. But what happens when that drive for efficiency becomes the enemy of security? Today, we're doing a deep dive into a report that really highlights this paradox. We're looking at how some of the simplest online tools, things developers use every day, ended up publicly exposing just the most critical secrets of some really massive organizations.
Yeah, and it's so important to set the context for you right away. This isn't your typical story of a sophisticated hack.
No.
Not at all. No nation-state attackers, no zero-day exploit. This was an exposure caused by a feature, a simple recent links section that, well, it had no security layer at all. It's a design flaw, really, that got amplified by just bad operational security from users.
And the scale is just, it's staggering when you look at the numbers. The report we're looking at from Watchtower, they identified and pulled down more than 80,000 user pastes.
80,000.
Yeah. And that adds up to over 5 gigabytes of data. We're talking credentials, keys, code, just sitting out in the open on these two sites, JSON Formatter and Code Beautify.
5 gigs of plain text secrets. That's an unbelievable amount of data. And when you see the kinds of companies involved, well, it's organizational gold.
Right. So let's get into it. Section 1. How did this actually happen? How do thousands of users, many with high security clearance, end up just publishing their company's secrets with a single click?
Well, the mechanism is, it's deceptively simple. Imagine you're a developer. You've got this huge, messy block of JSON code.
The total mess.
Exactly. So you paste it into a tool like JSON Formatter to, make it readable. And the tools are great for that. They work perfectly. The failure happens when you need to share that snippet, maybe just for a few minutes. You hit the save button.
And it generates a URL, a temporary link you think is private, right? Something you could just drop in Slack to a coworker.
That's the assumption. But here's the critical flaw. That unique URL, it's automatically added to your public recent links page.
Public, you mean? No login required.
No login, no session cookies, no authentication of any kind. The only thing stopping an attacker is figuring out the URL format for those pages.
Which I'm guessing wasn't very hard. If it follows a predictable pattern, like an ID number, you could just write a simple script to scrape every single one.
That's exactly what Watchtower did. The URL structure was predictable, so they could just automate the whole process and download everything. And this wasn't a new problem. They managed to scrape 5 years of data from JSON Formatter.
5 years.
5 years, and 1 full year from Code Beautify. This was a deep systemic design flaw that had been there for a long, long time.
And we're not talking about random users. The sources say this affected organizations in government, banking, aerospace, healthcare, even cybersecurity firms.
Which brings us right to Section 2.
Yeah.
What was actually in this data. The inventory of secrets is, well, it's breathtaking. Watchtower didn't just scrape the public pages. They found they could use the platform's own API endpoints.
The platform's own tools.
Yep. The get data from ID endpoints were also public. So if you knew the ID of a paste, you could just ask the server for the data and it would hand it over.
Wow. Okay, so what did they find?
It's pretty much an attacker's dream shopping list. They found Active Directory credentials.
The keys to the kingdom for a corporate network.
Absolutely. They found database credentials, cloud access keys for AWS and others, and private cryptographic keys, things used for signing and encryption.
And for anyone listening, a private key getting out isn't like a password you can just change. It can force a company to redo their entire security infrastructure. It's a huge deal.
A huge deal. On top of that, there were API tokens for all sorts of services, code repository tokens, and maybe most frighteningly, CI/CD secrets.
Okay, let's pause there. For anyone not in DevOps, explain just how bad it is if CI/CD secrets get leaked.
It's the highest level of trust you can have. A CI/CD pipeline is what automatically pushes new code into a company's live products. If an attacker gets those secrets, they can bypass all the human checks, all the code reviews.
And push their own malicious code directly into production.
They effectively become the company's deployment system. It's about as bad as it gets.
That really puts it in perspective.
It does. They also found payment gateway keys, SSH session recordings. Think about that. Literally watching a developer's keystrokes. And huge amounts of PII, including really sensitive know your customer data from financial institutions.
This is where we get to Section 3, and the specific examples are they're wild. The general list is bad enough, but let's talk about the real-world impact. What did they find from the financial sector?
So one of the biggest finds was from a major financial exchange. They found valid active production AWS credentials.
Which is already a nightmare.
It is, but it gets worse. These keys belong to the exchange's Splunk SOR automation system.
A SOAR, that's security orchestration, automation, and response. So an attacker wouldn't just be accessing data, they'd be controlling the system that's supposed to detect them.
Exactly. You get that key and you can turn off the alarms. You can erase your tracks. You can use the company's own defense system against itself. It's a massive force multiplier for an attacker.
Unbelievable. Okay, what about third-party risk? I saw a mention of a managed security service provider, an MSSP.
Right. This is a classic supply chain nightmare. The MSSP, a company hired to handle security for other businesses, leaked the Active Directory credentials for their own network.
Oh,
But they
no.
also exposed credentials for one of their clients, a U.S. bank that the report described as their largest, most heavily advertised client.
How does that even happen? Why would a security professional be pasting client credentials into a public website?
It all comes down to convenience over policy. You're trying to troubleshoot something quickly, you need to format some text, and you use the tool that's easy. It shows that you have to audit your vendor's actual practices, not just their paperwork. One click from a trusted partner exposed a major bank.
Let's pivot to government. The report mentioned a government entity, but it wasn't about passwords this time. It was code.
Yeah, this was really interesting. It was a paste of about 1,000 lines of PowerShell code.
So a script.
A script used to set up a new server on their internal network. And while there were no direct secrets in it, that script was basically a perfect blueprint for an attacker.
How so? What could they learn from it?
It revealed everything. Internal server names, how they configure their web servers, even the specific registry keys they use for security hardening. An attacker now knows exactly how their network is built and, more importantly, how to blend in and tailor an attack to bypass their specific defenses.
It's like giving them the architectural drawings. And now, for the ultimate irony, the cybersecurity industry itself. What did they find from a security company?
This one was just a gift to an attacker. They found what the report calls materially sensitive information from a company that was apparently easy to identify. It included encrypted credentials, sure, but also SSL certificate, private key passwords.
Which means an attacker could potentially impersonate their website, intercept traffic, a total breach of trust.
A total breach. And the paste also included internal and external host names, IP addresses, and the exact file paths to their most sensitive keys and certificates. It's not just a password, it's a detailed, annotated map of their entire security infrastructure.
It just shows no one is immune to this kind of mistake. And what was the last big example? Something about a data lake company.
Yes, a D-less data lake as a service company. In that case, someone had pasted an entire configuration file for their cloud infrastructure.
The whole thing.
The whole thing. It had domain names, email addresses, host names, and credentials for a ton of their core tools. Things like Docker Hub, Grafana for monitoring, JFrog, and their main RDS database.
They must have just been trying to format a huge, messy file and didn't even think about what was in it.
That has to be the explanation, and in that one moment of prioritizing speed, they expose the entire scaffolding of their production environment.
Okay, this all leads to the most critical question in Section 4. Was anyone actually looking for this data? It's one thing for it to be available, but were threat actors actively hunting for it?
And that's exactly what Watchtower wanted to find out. So they set up a really clever honeypot. They used a tool called canary tokens.
Right, those are fake credentials that alert you the moment someone tries to use them.
Exactly. So they created some fake, but very real-looking AWS access keys. They put them in a JSON file and then saved them on both platforms, specifically setting the link to expire in 24 hours.
So the idea is, after 24 hours, that content should be gone, right, inaccessible.
That's the theory. But what they found was alarming. The honeypot system lit up with access attempts using those fake keys 48 hours after they were first saved.
48 hours, so a full day after the link was supposed to be
A
dead.
full 24 hours after. This proves two critical things. One, yes, attackers are actively and aggressively scraping this data. But two, and this is the really scary part, they're keeping a persistent catalog. They are systematically testing credentials from expired or deleted links.
So it's not just a temporary exposure. Once it's out there, it's in their databases forever, and they'll just keep trying it.
Precisely. It turns a temporary slip-up into a permanent vulnerability.
So what about remediation? Do these big companies plug the hold?
Well, Watchtower emailed many of the affected organizations, and some did the right thing. They revoked the credentials immediately, but many just never responded. And the core feature, that public recent links page, it's still live on both platforms. The scraping can, and probably is, continuing right now.
So after all this, what does this mean for you? Whether you're a developer or you're running a security team, this whole deep dive just shows how a simple, innocent habit, using a public tool to format some text, can completely bypass billions of dollars of security investment.
I think the key takeaway here is that the information wasn't stolen in the traditional sense. It was voluntarily uploaded and saved in a public place. It proves that your biggest vulnerability might not be a flaw in your firewall, but a convenient external tool that your team uses every day without thinking. It's the human factor, amplified by a bad design decision.
And that brings us back to that honeypot finding, which I can't stop thinking about. If threat actors are still testing those links 24 hours after they supposedly expired, what other temporary things that you put online might be permanently cached and indexed by these automated systems? Think about all those temporary file hosts or code snippets. It's a sobering thought to leave you with as you review your own team's
A
habits.
very sobering risk to consider.
Absolutely. Thank you for joining us for the deep dive. We'll see you next time.